Okay, so we are starting with alternating current on AC. Now this alternating means it is changing. Okay, so what is alternating? Alternating quantity can be anything, not only current. Okay, it can be alternating voltage, it can be alternating flux, alternating electric field, alternating magnetic field, anything it can be. Okay, so what is the meaning of alternating here means? So alternating quantities, alternating 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 quantity alternating quantity alternating quantity can be any quantity, but what are the important features of alternating quantity? That quantity can be anything. So alternating quantity features. What are the important features of that alternating quantity? First feature is that it will be periodic. Okay, periodic function. Periodic function. Second, within within a cycle or period, within a cycle or period, the quantity the quantity must change must change its sign. Okay, must change its sign. For example, take example you take y is equal to sin x, y equal to sin x, y equal to sin x. If you take, so suppose if I draw this graph, y and x graph, so y equal to sin x graph is like this way, sinusoidal function like this. Okay, so we know that it is a periodic function, so 0 and this t. So this graph repeats after this cycle. So this is called one complete cycle. So for one complete cycle, the time taken is time period. So we know this time period is t. That time period is 2 pi. This time period is 2 pi, right? For one cycle. So that time period means here it is x, right? The value of x is 2 pi. Okay, that x is called one time period. Okay, so now this will be half of that t by 2, right? And the graph repeats. So first of all, it is a periodic function. Second is that within a period, the signs are changing. That means here it is plus and this is minus. That means first half cycle it is positive, next half cycle it is negative. Now it is important to note that it is not that within a cycle first half should be positive, next half should be negative. One quarter can also be positive, right? Like this, for example, suppose if I draw a graph, if I draw a graph which can be like this, okay, and this graph will be repeating. This is not a sine graph, but it's a different graph, okay. This is a different graph like this, and then this graph can repeat. Okay, this graph can repeat. Now here, this if you take 0 and this is like, let's say, time t, this is one cycle and the graph will repeat. But now you know that this is not the half of the time, this may be 1/4 also. Okay, it may be 1/4, but sign must change within a cycle. Sign must change. That is the idea. It is not important that half means half should be positive, half should be negative. It can be unequal duration also. So within a cycle, it should change sign. Where it change sign, when it change sign, that is not important. But it must change sign. That means alternating. Clear? Are you clear about this? Yes. Okay, so that is the meaning of alternating quantities. It can be anything. Alternating means it can be flux, it can be electric field, anything it can be. But generally the term AC has become so common. AC term has become so common that we use AC before any quantity. AC voltage, AC flux, AC, but that is not technically correct. It is alternating flux, alternating voltage, but the word AC has become so common that we use AC for anything, right? AC price is changing, right? AC anything you can use, but the actual word is alternative, right? Okay, so this is the feature. Let us move next. Next is important terms. What are important terms? Important terms. Important terms. Important terms. Okay, so suppose there is a quantity which is alternating, and the most classical example of sinusoidal function. So you have studied in EMI this formula of NBA omega sine omega t. Remember, this formula is the induced EMF formula. When there is a coil, let us say there are coils having n number of turns, and turns are there. Area of cross section is A, so this is the area vector, right? Area vector, and there is a magnetic field. There is a magnetic field, uniform magnetic field, like this, right? This is a uniform magnetic field, and this angle is theta, and this is rotating. So the coil is rotating with the angular velocity omega, anti-clockwise direction. So in this coil there is a EMF induced, and this is the formula for induced EMF in the coil, right? And BA omega sine omega t. How it comes? You know that because of electromagnetic induction, the EMF induced is minus rate of change of magnetic flux in the coil. So from that this result comes, right? Now you need to note that this EMF induced I can write as voltage V, and this NBA omega I can write as V naught, and this is sine omega t, right? So this type of classical function, which is like sinusoidal function or it can be cos function, they are standard, function which is alternating function. So sine graph we already know. So this type of sinusoidal function you will see in this chapter. This chapter will be full of this type of function. It can be current also, like I equal to I naught sine omega t, right? It can be magnetic flux, electric flux, anything like that. So sinusoidal function is there, but it may not be sinusoidal. It can be anything, right? In general, it can be any kind of function. Now here the first term we have to note is the peak value, peak value or maximum value, maximum value or amplitude, amplitude. Okay, so what is the peak value, maximum value, or amplitude? So if you take the sinusoidal graph, let us say this voltage graph, you see voltage versus time. So this type of function you will see like this sinusoidal function, like that it will continue. So here suppose it is 0, and this is one time period, and then cycle will repeat. So what is this? This is one complete cycle, right? One complete cycle. And here you can note that this is the maximum value, and this is the minimum value of this function. Maximum value is V naught plus V naught, and here minimum is minus V naught. So this V naught is called amplitude. Amplitude. So it is oscillating. The value is oscillating between plus V naught and minus V naught. Okay. So this term V naught, or here in this case I naught, these are called amplitude. This V naught is called amplitude of voltage or voltage amplitude. I naught is called current amplitude or peak value of current, right? These are called peak values, right? So that's the first thing, peak value. Then second point is called average value, average value, average value. So average value by definition, suppose any graph is there between x and y, right? So the average value of y, average value is defined as any type of graph it may be. Average value is defined as integration of y dx by integration of dx between the limits x1 to x2, between the limits x1 to x2. Okay, so in the numerator this is the integration of y dx, and in the denominator it is integration of dx between the limits. So integration of dx between this limit is nothing but delta x. Okay, delta x. So In the denominator, this will become delta x. Okay, and in the numerator that remains same from x1 to x2 y dx. Okay, this is called average value. For example, if you take voltage, and if I want to calculate average value, then the first question will come that average value from where to where. Are you calculating average value over one cycle or half cycle? That is the question. What is the time are you taking? What is the interval are you taking? So let us calculate average over one cycle. Okay, for one cycle. For one cycle. So when you calculate average over one cycle, you have to do V dt from 0 to 2 pi, because its cycle is 2 pi, right? And 0 to 2 pi means this time interval is 2 pi, right? This is how we calculate average. Now note that this integration of V dt gives area under voltage time graph. Voltage time graph area, that's what it is, right? Voltage time graph. Now if you see this voltage time graph here, here for one cycle, if you take, here it is positive, here it is negative. So this area is going to be positive, this area will give us negative, right? Equal amount of positive and negative area you will be getting. So that is why this term is going to cancel out and it will become 0. Correct? This term will cancel out and it will become 0. Why? Equal amount of positive negative area will cancel out. You do not have to do any integration. This result is a very standard result. Everybody can know that. Clear? But yes. Hmm. Yes. Okay. He left. Huh? Okay. No problem. Let him join. Might be some problem will be there. So let me continue. Okay. Okay. So no problem. Suppose you in between, if you have some issues, then okay, you can join. Otherwise, anyway, recording will be there. I will be uploading. You can watch also. Okay. So here it has become 0, right? Why? Because over a cycle, positive negative area cancels out. Let us calculate average of this over half cycle. Let us calculate average over half cycle. Okay, average over half cycle. So average for half cycle. So if I take half cycle, then I will take 0 to pi, because half cycle is 0 to pi. Okay, 0 to pi dt. dt 0 to pi, or I can write 0 to t. In general, I can write 0. Note that here this period 2 pi comes because we are taking a sin x, but suppose the graph is sin 2x, sin 3x, right? So in general, you note that in general I will write this as 0 to t, because over this cycle 0 to t it will be, here I will take 0 to t by 2. Okay. So 0 to t and this interval t. So that will be 0. Here I am taking 0 to half time, and this interval is also half. Okay, let us now calculate this. It is v dt integration. Let us calculate. Let us do this calculation. So here voltage is nothing but v naught sine omega t dt, right? 0 to t by 2 divided by t by 2. So let us do this calculation. So V naught comes out, sine integration, you know, it is minus cos omega t, and the coefficient we have to divide omega, and 0 to t by 2 you have to take divided by t by 2. And all of us should know that omega is 2 pi by time period. All of us know that means omega into t is 2 pi. All of us know. Let us try to substitute there. Hmm? Try to do the calculation average over half cycle. So V naught uh, uh, 2, I will write this side and it become omega t, right? And then I will put minus, then let us put this. So cos omega t by 2 minus minus plus cos 0. This is what we are going to get, right? Now, omega t is 2 pi, so omega t by 2 will become pi, and cos of pi is minus 1. We know that cos of 180 minus 1. So this will become 2v naught by omega t. Now let us also put omega t value. Omega t is 2 pi. Okay, and here it is going to be minus minus plus 1, and cos 0 is also 1. So that becomes 2 also get cancelled. So we get it 2v naught by pi. That's the important thing. So we are getting 2v naught by pi. This is the average value of voltage, 2v naught by pi, average value over half cycle, over half cycle, over half cycle. Clear? Yes, over half cycle, that is what is done. So they can ask over half cycle or full. So full cycle it is 0, half cycle you can remember 2v naught by pi. You can bring this in decimal form also if you want. Okay, 2 divided by pi you can check out. How much is 2 by pi? How much is 2 by pi? Okay, 0.6. How much it is? Yes, this Sam, Monish, approximately nearly 0.64 we can take, I think. Huh? 2 digit, let us take 2 digit. So average value will be, yes, 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 yeah, 0.64, correct, right. Okay, average value. Next we are going for RMS. Next third point is RMS value. RMS value. So RMS value, why RMS or anything RMS is calculated as root under y square integration of y square dx from 0 to, let us say, over one cycle. Here also one cycle you calculate. Over one cycle when you calculate 0 to this, and over one cycle time is t. This is what RMS means, root mean square. Okay, so square root of the means. Okay, so let us try to calculate VRMS over one cycle, over one cycle, over one cycle you calculate. So root under, we have to do integration of v square dt 0 to t divided by one cycle time t. So first we will evaluate the numerator. What is that numerator? Let us quickly evaluate the numerator. So v square means v naught square sine square omega t dt. So let us evaluate v naught square. Sine square can be written as 1 minus cos 2 omega t, right, divided by 2. This is what we have to do. Okay. So v naught square by 2 I have taken out. Then integration of 1 means it will give integration of 1 you do. I will directly do integration now. Integration of 1 will give t, and integration of this cos will give sine 2 omega t divided by 2 omega. And now we need to substitute limit 0 to t. Okay, we are taking over one cycle 0 to t. Now this result that I am going to derive, you have to remember it. Okay, try to remember this result, because this result, yes, 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 come in. Sin square theta is 1 minus cos 2 theta by 2. You know this formula, right? So the v naught square by 2 comes out. V naught square by 2 comes out. Then it is 1 only, because you open the bracket. So integration of 1 dt, integration of 1 dt will give t, right? Integration of dt will give t, and integration of cos gives sine, right? Cos integration is sine, and the coefficient gets divided, right, in integration. Okay, and then you substitute limit. Note that if you are taking over one cycle, the limit is 0 to t. If you are taking over half cycle, 0 to t by 2. Right, so let us take over one cycle. So v naught square by 2, put the upper limit you put t minus this sine of 2 omega capital T by 2 omega. This is upper value minus 0 sine 0, this is 0 and sine 0 is also 0, right. So now let us calculate this quickly, how much it is going to come. So this will become v naught square by 2 and t minus, so tell me 2 omega t. Omega t was 2 pi, so it will become sine 4 pi. Sine 4 pi is also 0, so this term is also 0. So everything is 0. So what you are going to get is v naught square t by 2. Clear? So that is what we are going to get. That is what we get. Now let us substitute it here. Let us substitute it here in this formula. So we are going to get v naught square t by 2 divided by t. So this got cancelled. So v naught by root 2. Clear? Yes. You may mute it, Kevin. Your mic noise will be coming. Yeah. Okay. So any time you can unmute and speak up because some background noises are there, right? So you can unmute and speak up. Otherwise, you can keep it mute. That will be fine. Okay. Done. So all of you got this. Yes. And also note that if you do RMS calculation over half cycle, so you will take 0 to t by 2. 0 to t by 2 when you take, what will you get? That also you think about it. Here you will get t by 2, right? Here you will get, this will again become 0. Note that. Okay. So over half cycle, only thing is this factor t will become t by 2. That is the only change will happen. Okay. Clear? So let us also calculate RMS over half cycle. Let us calculate RMS over half cycle. So RMS over half cycle. Same result will come or different result comes? Yes. What do you think? Same result or different result? 0 to t by 2 v square dt. Tell me. And time over half cycle means t by 2. So as I told, if you take over half cycle, so this factor will be t by 2. Yes, correct. This factor. Why? Because this will become how much? T by 2 means it will become 2 pi. So this will get anyway 0 again, because sine 0 is 0, sine pi is 0, sine 2 pi is 0, sine 4 pi is 0. So this term is going to be 0 anyway, right? So you will be getting this one as v naught square by 2, and this t will be t by 2. But again you have to divide t by 2 only. So you see t by 2, t by 2 again get cancelled. You will get v naught by root 2. Clear? Yes? Yes, all of you are clear. Kevin, are you clear? Sam, on is clear. Okay, done. So this is what it is. RMS value is like this. Okay, done. Now I will give you some question to calculate, and before that there is called form factor, that you note. Okay, in NCERT it is not there, but sometime in NEET they ask form factor. Okay, form factor of any function is given as RMS value divided by average value. Obviously they cannot take over one cycle, so you take over half cycle, over half cycle, over half cycle. So for sinusoidal function, we have already calculated RMS value. RMS is V naught by root 2, and this average is what? 2 V naught by pi, right? So how much this will come? Tell me. How much this comes when you calculate this ratio? Pi by 2 to 2. Approximately, I think, how much it comes? 1.11, right? This remember. For sinusoidal function, this comes like this. For sinusoidal. for sinusoidal function. Okay, so I think we have covered up to this much in the last class also. Okay, so this is total review of last class. Done. All of you are clear about this? Yes. Done. What, Kavin? Yes, both half cycle, full cycle, same it is coming. Not necessary. It is take quarter cycle for example. Take for quarter cycle here. So here time you have to change again 0 to t by 4. 0 to t by 4. Now tell me 2 omega t by 4. 2 omega t by 4 means omega t by 2. Omega t by 2. So this will come sin pi. Again it will be bit 0. Yes, you are correct. So for even quarter cycle also same result will come, because the second time is going to be 0 in that case also, right? Correct. So for quarter cycle also, quarter cycle if you take, then also RMS will come V naught by root 2. Quarter cycle, half cycle, full cycle, same. But I think if you go less than quarter, it will be a problem now. Because if it is less than that, then sign will change now, because less than pi it will come, right? In that case, let us say sin 45 degree if you take, then it is 1 by root 2. Then it will not be 0. Then it is a different result. Clear? Because omega t is 2 pi. Omega t is 2 pi. Right? Omega t is 2 pi. So if you take, let us say, if you take time 1 by 4, t by 4, if you take time t by 4. So t by 4, if you take, what will happen? It will become omega t by 2, it will become. Omega t by 2, it will become. So omega t by 2, how much it will come? Think about it. Check it. Not a big problem. Check it. Okay. Suppose if you take half 1/4 cycle, 1/4 cycle you take. Suppose over 1/4 cycle. So VRMS will be root under 1/4 means t by 4 v square dt. This will be t by 4 only. Okay. But what will be this quantity, integration of v square dt over 0 to t by 4? I will directly write the result. So v naught square by what was that? What was the result? Here v naught square by 2 was there, right? V naught square was 2 by 2 was there. So v naught square by 2, and this was t minus sine 2 omega t divided by 2 omega. You have to substitute 0 to t by 4. Substitute that. So v naught square by 2, and you have to put t by 4 minus sine of 2 omega t by 4, right, divided by 2 omega. Other term are 0 0 on this, that you leave it. Okay. Now you know that omega t is 2 pi. Omega t is 2 pi. So this is omega t by 2. Correct? Right? How much it comes? Check it. V naught square by 2. Put here 0 to t by 4. We have substituted already now. We have substituted. So this is t by 4 minus this become 2 omega t by 2. Omega t by 2 will become pi. That becomes sin pi, I think. That becomes sin pi. 2 omega. So sin pi is also 0, right? Sin pi is also 0. So again it is t by 4. So when you substitute here, when you substitute this here, what happens? This t by 4 will get cancelled again, because in denominator we also have this. Correct? That will again get cancelled. Huh. No, no, this 2 omega is coming due to integration. That 2 omega is due to integration, because when you do cos integration, coefficient gets divided. That coefficient is huh. This one. Yes, this one, right? Huh. You substitute now. Suppose you get 45 degree. Then 1 by root 2 you have to substitute, right? Sine 45. Omega will remain as it is. Omega you can substitute now. Omega is 2 pi by t. You have to substitute that omega. Correct now? You need to substitute that omega. Do not worry about the units. Units are same because t is time and 1 by omega is also time. Okay, 1 by omega is also time. So don't think that the units are different. They are the same units. 1 by omega and time t are same time only. Okay. So here also if you take one cycle, it is also same result. Okay, same result it is coming. Yeah, yes, Kevin. Tell me. Where? Here. No, no. Suppose if you take one eighth cycle, you take one eighth cycle. Suppose you take one eighth cycle, then here pi by 2 factor will come. Correct? Correct. One extra half will come. So sine 90 will become 1, and so this will become t by 8. T by 8 minus 1 by 2 omega will be there. Okay. Are you getting? So this will remain like this. Okay. Suppose if you take over one cycle, over one eighth cycle you take, one eighth cycle. So in that case, this calculation which you are doing, v square dt 0 to t by 8, here this term will be same, v naught square by 2. This will be t by 8 minus this will become sine 2 omega into t by 8, and this is 2 omega, right? So, also note that we know that omega t is 2 pi. We know omega t is 2 pi. So, omega will be 2 pi by t. We can convert omega in terms of t. So, no need to worry about that. We can convert. Now, you see here, this is V naught squared by 2 and this is t by 8 minus. Now, you see omega t is 2 pi. So, this is 4 pi by 8. That means pi by 2 sine 90 degree will become 1. 1 by 2 pi you get, right? Now, 2 pi you substitute. Omega you substitute now. So omega you substitute. So V naught square by 2 t by 8 minus omega you substitute. So 2 omega will become 4 pi by t. So it will become 4 pi by t means it will become like this. Okay. So from here V naught square by 2, and let us take t by 8 common. T by 8 common if I take, so 1 minus 2 by pi it will become 2 by pi. Okay. So this is what you will get. Now let us calculate RMS value. So when you calculate RMS value over one eighth cycle, over one eighth cycle, then this factor you have to substitute. V naught square by 2 into t by 8, 1 minus 2 by pi divided by t by 8. So this t by 8 factor will get cancelled. Okay. So now you will get the result as you will get a result of V naught by root 2, but there is extra factor coming inside that, 1 minus 2 by pi. Are you getting this? Yes. Yeah. So, after doing so much half time, then you are getting this. Otherwise, all formulas are same. Over one cycle, over half cycle, over 1/4 cycle, till that same RMS value. But when you take 1/8 cycle, then you get this answer. Okay. Generally, they don't take RMS over 1/8 cycle. Generally, they may take over half cycle or full cycle. That's all. But it is a good question. In NEET, if they ask, suppose in NEET, if they ask, what is the RMS over 1/8 cycle? This will be the answer. So now it is better to remember it, because quickly you will choose the correct option, right? Done. Monish, clear? Okay, done. Done. Now I will give you question. See, the thing is that whether you are NEET or whether you are JEE or whether whatever you are, only my goal is that you should be able to understand and do calculation, because you are grade 12 student. Okay, so you should be able to do calculations and you should be able to understand things. If you are not able to understand, you can ask any amount of question, that does not matter. Okay, in my class you can, maybe the full class can go question answer, it doesn't matter, but you have to understand, that is the thing. Okay. Okay, so let us take question now. I will give some question and now tell me what it is. DC already you have studied na, whole current electricity was DC only, right? Correct na? It was direct current only. The DC means it is constant na, voltage is constant, it is not changing. Suppose 2 volt battery means 2 volt only, it doesn't change with time. Okay. No, no, no. DC is always stable. Okay. Ideal DC, always voltage is constant. Voltage does not change. Current does not change. Right. AC only you have to study, because current is changing, voltage is changing. Right. Things are changing. So there only alternating quantity concept comes. Right. Okay. Yeah, yeah. Stable unstable means what? What is stable unstable means? It is changing. Ah, ah. That is what is alternating now. Alternating is changing, right? See, stable and unstable can be in electronic circuit where you are having a voltage regulator. Voltage regulator means voltage should not go beyond this limit. If voltage go beyond this limit, then it will be unstable. Voltage lie within that limit, then you can see stable. Within that limit means it can change, it can fluctuate. Like in the home, the voltage electric supply which is coming within a limit it is. If it goes beyond that limit, then it become unstable. Things will damage. Electrical appliances will damage, right? So stable, unstable means there is some regulation is there, some peak values there, maximum, minimum, right? So the graph should lie within that. Okay, right? Okay, so let us take a question. Let us take a question. Suppose the voltage is V is equal to V naught T. Okay, V equal to V naught T. Find RMS voltage. Find RMS voltage over one cycle. Now you may ask, where is the cycle? I will draw the graph to show you. Okay, this is V graph versus time, and the graph is like this. Okay, like this. After that it becomes like this, and after that it continues like this, then it continues like this is continuous. So if you talk about one cycle, so this is your one cycle, here it is positive, after that this is one cycle, after that it continues. So this graph is given. Okay, this is maximum value is v naught, this is maximum value v naught, and this is 0. This is the cycle time t. Okay, and this graph straight line which I have drawn, this graph is like this. First graph is like this, second graph is parallel to that graph. Okay, so this is here, the lower limit is minus v naught. Okay, like this. Okay, now you need to find the over one cycle RMS value you have to find. These are parallel lines. Okay, these lines are parallel lines. How do you solve this? So, so first of all, this graph is given, function is given, only straight line, but this straight line equation is only for this. Other you have to think about it. Other you have to think about it. For one cycle, this. Hmm. No, no, see here, V naught by root 3, you calculated RMS over half cycle, right? Now see the graph is symmetric, right? Graph is symmetric. Just like in case of sinusoidal also, it's like half time period, okay? Half time. It is a symmetric graph. So RMS over half cycle and RMS over full cycle is going to be same. So your answer will be same V naught by root 3. Okay? V naught by root. That is shortcut. That is shortcut. But if you want to calculate over this interval, then you have to find the function of this. You need to find the equation of this line, right? You know this equation only. You need to also find the equation of this line. So what will be the equation of this line? What is the equation of this line? How do we know that? How do you know that? Hmm? Equation of a line, how do we calculate? Yes. So you can think like this. Suppose if you take this line, right, and let us say that you extend this line. This line, if I extend it, so because it is symmetric, right, because for half time it is V naught and for full time it will be 2 V naught, because this ratio has to be same, this angle is same. This will be minus 2 V naught, correct? So here it is total time is T here, correct? And here it will be minus 2 V naught, okay? So if I want to write the equation of this, if I want, remember there is a line suppose, and if this line make intercept with x-axis as A and B, A is this intercept and B is y-intercept. What is the equation of this line? Do you know that? What is the equation of a line which makes x-intercept as A, y-intercept as B? Can you tell me? Anyone? No, this equation is x by a plus y by b is equal to 1. That's the equation of the line. You should know this is called double intercept form. These are very basic maths. Now in grade 11 we are teaching this basic math coordinate geometry. You are supposed to know that. If a line is cutting axis, A is the length on x axis and B is the length on y axis. Then x by a, y by b. Okay. So here you see what is the length on x axis T and what is the length on y axis is minus 2 V naught. So this equation of this line will be x means time it is. So time divided by this total time is T plus y means voltage divided by total intercept here is minus 2 V naught is equal to 1. So from here now you can calculate. Okay, so V by minus 2 V naught, or this I will take that side. Okay, let us take that side. So V by 2 V naught is equal to, that will come here, so T by capital T minus 1. Okay, T by capital T minus 1. So from here this equation of V will become 2 V naught V naught t by t calcium t minus capital T divided by T, right? Okay, that will be the equation of that. Right. Correct. Is this correct? Check out. Because that's the equation, x by a plus y by b equal to 1. So here x intercept is t and y intercept is minus 2v naught. So x by a means this x means time axis t by capital T. Y intercept is capital V by this intercept minus 2v naught is equal to 1. So v by v naught come that side. That is the equation. Okay, that is the equation. So now you know equation of this line and equation of this line. You know that. Suppose if I have to take now over full cycle. Okay, let me take over full cycle. So full cycle when you take, so you need to write this function first. First let us write V equation. Equation of V is V naught into T. This equation is valid from time 0 to half, correct? Half cycle. Here to here, half cycle this graph. After half cycle, from half cycle to this, what is that equation? After half cycle to this is the equation, right? 2 V naught by T t minus t, right? This equation you will use over next t by 2 to t. Okay, so you have two equations because these are two different lines, this line and this line. This line equation is given, this line we have equation calculated. Okay, now you use this integration. So while you are trying to calculate integration of v square dt over one cycle, you have to break this 0 to t by 2 v square dt and t by 2 to t v square dt. Why you need to break it? Because the graphs are different. Okay, graphs are different. So this type of function are discontinuous. So within this graph, after this graph. So you need to break this into two integrations. Then you can do this integration. To try this integration, try this. This integration I think you have done. This is v naught square t square, right? V naught square t square integration you have to do. Okay, and this time is 0 to t by 2. And this integration also you have to do. V square means here it is becoming 4 v naught square by t square. Okay, and then this integration is t minus capital T whole square dt. You are going from t by 2 to t. This integration you have to do. Let us check that integration. So v naught square t square integration is t cube by 3. 3 I will take here and take the limit 0 to t by 2. Okay. Then here 4 by t square comes out. V naught also is come out square. Here this whole is like a square. Whole is like a square means you can take a whole power 3. Whole power 3 by 3 will come. So 3 I will take out. And then we have to take from t by 2 to capital T. Okay. So let us try to calculate this. So V naught square by 3, this become t cube by 8, 0 is 0 anyway. Okay, this one. So 4 V naught square by what it will be 3 is again here also comma t square. Here you need to put upper limit first. So when you put upper limit, t minus t becomes 0, right? T minus t becomes 0 minus lower limit. Lower limit is t by 2 you have to put. So t by 2 minus t is minus t by 2. Minus t by 2 whole cube will become plus here and this will become t cube by 8. Here also it is becoming t cube by 8. Check that. Correct? Because you need to substitute limits now. How do you substitute limit? First you put upper limit. Okay, so t minus t whole cube minus and then lower limit t by 2 minus t whole cube. Now you calculate. Check this. So V naught square by 3, right? V naught square by 3, and then this will be t cubed by 8 plus V naught square by 3. This is 4 by t square. I am separating V naught square by 3. And then this will be 0 minus. This cube will give minus, right? So minus minus, that's how plus it is. T cubed by 8. Okay. So what are we going to get from here? So V naught square T cube by 8 into 324. Let us take common. Let us take common. Right? This. Here also 8 into 324 will come out. Right? It will come out. So 4 by T square is extra factor, it is coming. Correct? 4 by T square is coming as an extra factor. Okay. So this is what it is. But the thing is that I am thinking that somewhere something is not correct, because it should come also as a number. What do you think? You're also thinking like that, huh? It should give some number, it should give, right? Where is the mistake? Yeah, yes, yes. Huh. Hmm. Where this angle is theta, right? Correct. Hmm. This, so the slope of this graph, slope, right? Slope of this graph is, let us say m. M is the slope. So slope is V naught by t, right? V naught by t is the slope. V naught by t by 2, sorry, V naught by t, because this is t by 2 and this is V naught. So slope is V naught by t by 2, means 2 V naught by t is the slope of this graph. Correct? Take tan theta. Suppose if I take tan theta in this bigger triangle is smaller triangle. That is what you are saying? Yes. Yes, yes. Tan theta is constant only, correct? No, what we are doing is we are finding the equation of this line and then integrating. That is the definition. So, is there any mistake in this integration? I mean, so integration, no, equation. Is there any mistake in equation? The idea is that we want to calculate this line equation. So, is this line equation correct or not correct? That is first thing we have to check. You can try to calculate equation of a line by different method also, because you know this point, if you take this point, this is t comma 0, this point is t comma 0, and point is there and slope is there, you can also calculate. Yes, Kevin? Without calculating, line equation is not needed. What do you say? Line equation is needed or not needed? Hmm. Hmm. First, this integration you are taking, okay, tan theta is okay, then V naught you are writing is like this. V naught. No, no, what happened to t? You have not taken that. You have taken only V naught square you have taken. T square, where is t square? No, no, this you have done over half cycle now. Half cycle we have already got this. Half cycle we have got. We are taking full cycle. See, half cycle we have already got this. Half cycle, no problem is there. Okay. Full cycle we are talking about. No, no. To do that you need V now. V function you need now. What is V for the second graph? Second line will be this equation now. You need to know equation, right? Without knowing equation, how can you do that? That is what. Huh. So where is that mistake? Tell me. This is the equation of line. X by a plus y by b is 1, right? So this line is going like this. The x intercept is t, y intercept is minus 2v naught. Ah, that is what it is. Everything is in front of you. So v by 2v naught. It is t by t minus 1, right? So v is equal to 2v naught. T I have taken LCM, t minus 2. Where is the mistake in this? Tell me. Now this same equation I will try to derive by slope form, point and slope form. So point and slope, this point is t comma 0 and slope is tan theta, which we know. So suppose if I write this form, slope and point form, so I can write y equal to y naught, y equal to y1. So y1 here is 0 plus slope is 2v naught by t m x minus x1, x means t minus capital T. That's the equation, right? This is this y means this is v voltage equation, right? You see, one step also we can get to the equation. There is no problem. Okay, this equation is correct. There is no problem in the equation. There is no problem in the equation. Okay, so this is the equation for this, and also you can check whether this equation is correct or not. You can put t equal to capital T. When you put t capital T, it will be 0, right? This function is 0 here, right? And if it is less than t, it is negative. You can check. If it is less than that, it is negative. There is no mistake in that. Okay, mistake is not there. Okay, the integration you check, is there any mistake? 0 to this over half cycle will be this, over half cycle will be this. Okay, 0 to this over half cycle it will come. Then this next half cycle you take, next half cycle you take. So when you are taking v square, 2 that become 4 v naught square by t square and this whole square, and we are integrating. When we are integrating, this whole square we are taking, so whole power 3 divided by 3, right? This is also correct. This is correct. This time is this side. Okay, then here you are substituting time, upper and lower. So when you substitute this, okay, when you are substituting this, so t minus this will be 0, and you will substitute half, so it will come negative, and then you will get this one. Okay, you will be getting this one, right? After that, what will happen? So anyway, whatever we are getting, let it keep it like this. Now we need to think it. Has there any mistake here? Was there any mistake? No mistake was there. Here, is there any mistake? No mistake is there. Is there any mistake? Check the mistakes. If there is no mistake, then this is what we are getting, integration of v square dt over 1 cycle. That's what we are getting. And if you are getting this over 1 cycle, then you calculate Vrms over 1 cycle. So root under this one, this vector become V naught square t cube divided by 24, 1 plus 4 by t square divided by 1 cycle time is t. Now try to cancel out. So what you will get as V naught will come out, t square will come here, t square also you can take out, correct? V naught square will come, t square t will come, root 24 if you want you can take out, otherwise if you want you keep it inside. Okay, so it will remain 1 by 24, 1 plus 4 by t square. This is the answer coming over full cycle. Check this calculation. But if it is half cycle, then this factor was coming and then divided by what? Divided by half. T by 2 we have to do in that case. See, over half cycle we have to do T by 2, correct now? T by 2 over half cycle we have to divide. Then when you divide T by 2, what will come? For half cycle you calculate. For half cycle, check that once. Over half cycle when you calculate. So VRMS will be what? This factor only will come over half cycle, right? So root under V naught square by 3 T cube by 8 divided by half cycle time is T by 2. Now you tell me. I think V naught by root 3 will not come. You check this calculation. T also will get cancelled. T square T also will come. So V naught T will also come. Here 4 will come. Correct? 4 is also coming. Correct, right? So 2 will get cancelled. 4 into 3, 12 will come. So root under 12 will be coming. Check this. Yes, this is the correct answer. Okay, this is the correct answer. So you may think why it is correct, how it is correct, but what is mathematics says that is what is correct. You have to believe that because that is the calculation coming. Now you may say dimension has not matched. Correct now? Yes, dimension has not matched. You will say that here how t square is coming. Correct? This should be a number, right? Right or not? Now you think. Now you go back to the question and read the question. What equation was there here? Here if you read this question, V equal to V naught into T. First of all, here itself dimension is not correct. Because this is voltage, this V naught is voltage and this is T. V naught is not voltage, V naught is a number, that's all. And that number or quantity doesn't have same as voltage. Okay, right? So dimensionally you cannot check because V naught is not same as voltage. V naught is something else. Its units is something else. Okay, are you getting that? So this equation is where people will make mistake because they may think, okay, how it is here it looks nice, but this integration is not giving correct. You will start judging things, but the thing is that you need to first itself judge this equation before integrating. This V naught is not the voltage, right? So if you ask what is the unit of V naught, V naught unit will be what? Now tell me what is V naught unit, because this is voltage and this side also should be voltage. So V naught unit will be voltage per second. V naught unit will be voltage per second because voltage per second into second will give voltage. Are you understanding? So V naught unit is voltage per second. Now you match the dimension in the last step. Check that. Okay, so V naught unit now you take and match. It will come. It will come. Okay, it will be coming. It will match. Don't worry, that will come because this is what is calculation. V naught is a constant. So what calculation it gives, that is what is the answer. Okay, then understood this. Yes, yes. Half cycle, another answer will come. Another half cycle, another answer can come. It is possible. It is not that. Uh, uh, hmm, hmm. No, no, no. You take the graph of V square now. You draw the graph of V square here. Suppose if I draw the graph of this V square graph, if I draw, how will V square graph look like? Okay, V square graph how will look like, because in sine function this graph is like this V square graph. That's why over half cycle or over full cycle this is same. But in this case draw the V square graph. How will V square graph look like? Can you draw that? First let me draw V graph. V graph we already draw, right? Then let us make that V square. So this graph is V graph first. So V graph we have seen. V graph is like this way and then it is going like this way. like this it is going. So this is one complete cycle. Okay, now let us take in the same, if I make v square, v square line will go like something like this. V square may go like this something. Okay, v square will go like this, correct? V square will go. Now the thing is that how this square function may look like. This you take from this point onward. Will it also be same, because this point is same, so symmetrically it should convert, isn't it? Will it be also like this way? Yes. Will it be also like this way? V naught square. And if I take further next, so I think the graph should V square graph should repeat it like this. Is it like this? V naught square graph. Is it like this or something different? And then you learn graph you have to learn now. So see, that's why if you do not know this graph now, what we need to do, we have to write equations, right? So what is the equation of this graph? This graph equation was v naught t. When I square this, of course it is not, now I got it. Tell me, this will not be a straight line. This will not going to be a straight line now, correct? This will be going to be a graph now. This will be a non-linear graph, correct? The square of this means it may go non-linear graph, like this way it will go, correct? Some function like this way it will go, correct? That so this will become v naught square t square, because it will become like a parabola. Okay, then this may also become parabola, and whether it will become symmetric or not, we don't know. That those who are expert in math, they can only draw. I'm not an expert in maths. Okay, so, so I can tell you up to this much. After this much, you think about it. Okay? The graph will be we don't know, but it will be parabola, because that is also parabola. That is also parabola. Okay, that graph is also going to be parabola, but what kind of parabola is it? Will it be like this type of parabola or some different type of parabola? That you need to check actual graph. Okay, so but the idea is that if the graphs are symmetric, it is coming, so hopefully it should be same. But if it is not symmetric or symmetric, everything will come from calculation only. Everything will come from integration only, because that integration you have to do. You cannot simply say that it will be symmetric, so it should be, equal. You cannot say, because you need to perform the integration. After performing integration only you can judge that whether it is same or not. Okay, and if it is coming same, then it's same. If it is not coming same, not same, correct? That you have to do. We have done integration, right? We did the integration. But in NEET, what they will ask? In NEET, they will not tell anything. Just they will give the they will just give v equal to v naught t. Okay, they will simply give v equal to v naught t, and they will ask find RMS, find v RMS from time 0 to time t is equal to t. That's all. Simply they will give that. Okay, simply they will give. That means they will not show it as alternating. They will simply give a function. They will simply give a function. A similar question has come, I think, some previous year. They will simply give a function and they will ask you to calculate RMS. So you will just calculate RMS by basic definition. So v square become v naught square t square, and then you will use v square dt over 0 to t. Whether it is one cycle or not, we do not know, but it is given. So you calculate this, right? So v naught square t cube by 3 will come, 0 to capital T you will take. So v naught square t cube by 3 will come, right? And then when you take RMS, you have to take under root of this, which is v naught square t cube by 3 divided by time t. So from here you will get v naught t v naught t by root 3, correct? This will be the answer, Correct. Are you getting? T factor will also come. Don't think this T will get cancelled. Okay. Suppose V naught is 1. Suppose V naught is 1 or this time is 1. Capital T is 1. Then it will be V naught by root 3. Okay. So it is not that it has to be V naught by root 3, V naught by root 2. It depends on what function it is. You are getting this? Yes? Done. Understood that. All of you have understood this. Now tell me very quickly one question I'll give. Tell me, suppose this V equal to sine square omega t. Okay, this is this equation. V equal to this. Now you tell me what will be the average value over half cycle 0 to pi. Okay, or let us say this is uh, 0 to omega t. It is you have to calculate average V average over half cycle. Can you calculate? Find V average over half cycle. Huh? No, no, not RMS. This is average value. Okay, let's add that question also. Find RMS also. Find VRMS also over half cycle. If you want, you can add a term V naught here. Okay, so let us keep this equation V equal to V naught sine square omega t. So let's do that. So first average value calculate over half cycle 0 to 3 by 2. So V average is equal to integration of V dt over half cycle 0 to t by 2 by t by 2. So this will be 0 to t by 2. V is V naught sine square omega t dt. Sine square I think we have to do, correct? So do that. 2 V naught by t. Sine square, break it, sine square, break sine square. How will you break it? Sine square theta, you know. 1 minus cos 2 theta divided by 2, correct? This 2 also will get cancelled. Okay? So V naught by t, uh, t it will come minus. Um, now integration we are doing. Okay, one integration is t. Cos integration is sine. Sine 2 omega t by 2 omega. Yes. Put the limit 0 to t by 2. To quickly do that. So tell me how much it will come. T by 2 minus this will be 0 only, correct? This will be 0, 0. Leave it. This is 0. So we got V naught by 2. That's the average. Average value is V naught by 2. That is the answer for this part. Okay, so the answer will be V naught by 2. Okay, RMS you do. RMS now it is very difficult. RMS, how will we do that? RMS there will be problem now. First, for calculating RMS V square, we have to do calculation. V square dt 0 to half cycle. This itself will be now a problem for you. So this becomes V naught square. Sine square will become sine power 4. Oh, how to do that? Huh? How will you do this? No. This can. Neat. This is neat only. Neat only. They will ask this. How will you do that? Neat. For that, you need to think how to convert sine power 4. Like here, sine square you converted, right? Sine square you converted. Similarly, you need to find some trigonometric formulas. Trigonometric formula you have to find out. Okay, so I am giving this as exercise. Huh? Take this as exercise, your homework. Homework. But some formula which I can tell you is that some idea is there. What is the idea? That sine 4 omega t can be written as sine square omega t whole square. Okay, right? And sine square omega t we can break it, right? Sine square we can write as 1 minus cos 2 omega t divided by 2, and we have to take whole square. Okay, so this will become 4, it will come, right? Then a minus b whole square we have to do. So a square plus b square, a square plus b square minus 2ab minus 2 cos 2 omega t, cos 2 omega t. Okay, like this will come. Okay, so again this cos square function we can now break it, cos square. So this cos square 4, 1 by 4 I am taking out. Okay, 1 plus cos square I can write as 1 plus cos 2 theta. Cos square theta is 1 plus cos 2 times. That will become 4 omega t. Okay, divided by 2. So this term minus 2 cos 2 omega t. So now if you take LCM everywhere, so you will be getting this as 1 by 8. This will become 2, 2 plus 1, 3 it will become, right? 3, and it will become cos 4 omega t and minus 4 cos 2 omega t. This is what it will come. Now I think integration of sin 4 omega t can be written as integration of this whole term. Yes, correct. Huh? Right. Right. So integration of v square dt when you are doing, so which we have got v naught square, so v naught square will come out, and sine power 4 is going to give this. So here 8 I have taken out, so now you have to integrate this. So integration of 3 will become 3t plus integration of cos integration will be sine 4 omega t by 4 minus 4 cos, again integration will be sine 2 omega t by 2 omega will be divided. Okay, this is what you have to take 0 to t. Well, let us do it fast quickly. So what you will be getting here from here is v naught square by 8. Substitute, this is 3 into t by 2 plus sine will again become 0. Again it will become 0. So finally you will get v naught square 3 v naught square t by 16. Correct? This is what you will get. Otherwise, if you want, you keep it like this, because t by 2 factor will get cancelled. So v naught square by 8 into 3t by 2. This is what you get. Now calculate RMS. So now VRMS is equal to root under this factor, which is v naught square by 8 3t by 2 divided by t by 2. So t by 2 cancel. Now we are getting v naught square by 4 into 2. You can check out this, right? So I think this will come under root, right? This will come under root. V naught square will come out. So that will become V naught root under how much? 3 by 8. Correct? This is the answer. Did you understand this? Trigonometry. It is all the game of trigonometry. If you know trigonometry well, then you can play this game very nicely. Otherwise, you will be out. Okay. So you have to learn this trigonometry. Now, suppose in NEET, if they ask this question, unfortunately, then you can only solve it because you know this result. Okay, so that is what is the power of doing all this calculation. You have to record all this in your notebook, that integration of this sine power 4 will give this. Okay, this result RMS. But those who are doing that calculation, it will take 10 minutes in the exam. Every 1 minute is important. Okay, so these results you have to remember that. Okay, clear? Done. So now you work out problems on this whatever with. So today you can work out question on RMS, average, like all these type of calculations of this. I'll also send some question in the group, you can work out. Fine. Okay, then we'll see next class. Fine, we'll continue. Yes, tell me. Ferromagnetic, when you heat and when its temperature go beyond Curie's temperature, then only it follows that law. Below Curie's temperature, it will not follow any law. Okay. No. That Curie's law is for paramagnetic substance, that you have to note. Curie's law is for paramagnetic substance. When ferromagnet converts into paramagnet after its some temperature, then only it follows that law. Okay, that you should know. Hmm. Yes. At that temperature, Curie's temperature, ferromagnet will convert into paramagnet because the domain structure gets damaged, and then it becomes paramagnet. Then when it becomes paramagnet, then it will follow Curie's law. Okay. Before Curie's law or below Curie's temperature, it will not follow Curie's law. Okay. Done. Ah. Oh, periodic test. Okay. And option was paramagnet was there or not? Adjacent region question. Okay. Hmm. No. That is what ferromagnet will follow, but that adjacent is statement is not fully correct. It will follow after Curie's temperature, not before Curie's temperature. No, but assertion itself is not correct now. Assertion itself will not be correct. If they say ferromagnet follows Curie's law, that its statement is itself wrong. It follows, but after that Curie's law. Then in reasoning, they can say that they can write actually the formulas that after this, that is the Curie's law, and that is what they follow. Okay. So adjacent region is quite a very complex type of questions because the interpretation can be sometimes different. Okay, things are not clear now. Then interpretation somebody can make some interpretation, and then that is a very much ambiguous. It is right. Things should be straightforward. Correct. No, for your case I not same. Yes, same question is na for JEE. Okay. I will check that. I will see that. Okay. Okay, then we'll see. Don't worry, whatever it is, they will correct. But you need to learn what is the right thing. That is very important. Okay, because here, no, here some even if sometime wrong, we may give you marks, right? Because they may not be very strict. But in your final exam in CBSE, nowadays it's going to be very strict. So because they are taking marks based on that scanning, then automatic is there. They will cut marks otherwise. Okay. So you have to write to the point, exact assumption region, and any controversy happen, then CBSE will take care of that. They will give marks or whatever they have to do. Okay. Fine. Okay, then we'll see next class. Yeah. Bye bye. Right.